Hello and welcome to the DataOps channel. My name is Simon Salim and I'm here once again to bring up a new topic. And this time I want to do a continuation of my previous Medium post around blue-green deployments, but of data itself. I also had quite an interesting discussion on LinkedIn around this subject, and it's very wide, and a lot of people tend to view blue-green deployments quite distinctively with applications themselves. But there are ways to achieve similar outcomes, but with data itself. However, it's a completely different universe with a range of different problems. So let's try to dig into it and see what we can get out of it. Also, for anyone watching, I would highly appreciate if you like and subscribe. Only around 6% subscribe to my channel who's watching the videos. So the more I can get this number up, the more I can do videos that you want to hear. And this topic that I'm talking about today actually comes from a viewer who was asking about these things explicitly. So I like to give more than I receive. Anyway, let's dig straight into it. All right. All right. So before we dive into blue-green deployments for data, we need to just quickly have an overview of blue-green deployments in general from an applicational standpoint. The concept is the same, but the use case is a bit different. So essentially what it means is that you have some existing deployment, which is, let's say, an app in production. You have some interface at the end here. Let's make it yellow. This is, some, let's say, user layer of some kind. And what happens now next is that, okay, you want to deploy a new version of this one, but without having any downtime. So you have some kind of router service. If you use Kubernetes, this might be Argo CD, it could be something homemade, cloud providers have it, etc. It doesn't really matter. But the point here is that right now, the live traffic goes like this. And what we do in a blue-green deployment now is that, okay, now we will spin up a new one. So this is going to become the new app in prod. And what this will do is it will redirect this one. This one will start using this one. So once this here is checked, ready to go, we will delete this one, and this connection here will go away, disappear, and it will switch over. And now this one will become the blue one. And then the story repeats itself next time somebody wants to do something. But that's, in its essence, is what a blue-green deployment is. You just make sure that you have zero downtime. And now let's discuss how would we do this with actual data in a data analytical or research or data science way. So the first thing we want to think about, going beyond software engineering, the traditional blue-green deployments, is okay. How do we want to do this within data? Well, one of the first thing why you want to do this is to create some type of management of breaking changes. So updates to datasets, models, or tables can disrupt existing pipelines or analytics or any type of consumer of the datasets. So applying the blue-green principles to data, we can essentially achieve something very similar to what you do in a blue-green deployment with providing the most up-to-date data with no downtime for the users. Um, we, however, beyond this, also need to create some type of isolation, because one version of the data might be what one user wants versus a new change to that data might be what another user wants. So that means that we need to create some kind of isolation for data for testing. So ultimately, that kind of branches off into that data engineers, scientists often need production like data for training models or doing analytics, integration tests, etc. But we want to do this not on the expense of the live system. So, to give you an example, you might have a live dashboard that is used by the business to visualize very important metrics that the business takes decisions on. At the same time, you might have a data scientist using those same outputs to do some kind of forecasting or prediction, and uh, you might want to do improvements on the forecast or predictions, which means altering the data set. But you want to use the real thing. Okay, so how do you do that? And essentially, everything I've kind of spoke about now is, supporting user-specific testing and multi-user, uh, multiple users wanting to do changes and modifying the source of truth. Um, and this is very challenging. So let me just dive in a little bit into how this can work uh, practically. Okay, so this is a live drawing from my Medium post where I talk about these things. So essentially, imagine you have an analyst, scientist, or data engineer. They use various different frameworks. This doesn't matter too much. This is just to illustrate that a data engineer might be using Spark, a scientist might be using Delta RS or DuckDB, and equally an analyst might be using dbt. So they might be working on different branches of the truth of this data, and they might propagate this at different times. And more likely than not, uh, since we want to do this with as live like data as possible, we can essentially create a separation between storage and compute. So the live compute in this case might be a Trino cluster, right? Which might feed some kind of dashboard to, in this case, table X. And Trino doesn't have any storage, right? So it keeps its storage in this scenario with an example of Delta on S3 through a metastore. And this means that whatever that dbt model defined as the source of truth for table X, that propagates, it's stored in its storage, and you have a live prod cluster that queries this data and provides the output. And with the kind of blue-green deployment in mind, what you can do is you might have then a data engineer who wants to provide a new version of this data set for a scientist. So they might go alter this. They can use a staging Trino cluster, which has access to the live data. But without altering the live data, you can create a replication under a user specific schema. So in this case, silver and then the user's name, table X. And now all of a sudden you have a pure one-to-one replication of the originating table, which then can be used to do downstream analytics and live mode testing, and this can be replicated in multiple ways. So this approach is quite neat, but it has some limitations to it. So for example, you will be potentially cluttering the storage layer, since you would have a replication of the data itself in multiple places. And one could argue that you could always use this data and just read different versions of that data depending on your user, because you get that out of the box with Delta. But it's not that simple, unfortunately. So, for example, if I have this table here, which is live, I do a live change, it propagates through. in the world of Delta or an Iceberg or any other open table format, the latest version is the latest version of that data. So that means that if other users are not aware of this, you might run into some trouble. So you might have been in a similar situation where you might be working in a station environment and you want to alter a data source, and you're two or three people playing around with the same data set. So the truth of the analyst is not the truth of the scientist, which is not the truth of the data engineer. So you all try to go and read this like in a dev environment, but everyone's doing changes to it at the same time. Then this approach is great because then you can completely isolate and the user does not have to worry that the version might change. So there's no need to keep track of that. Um, However, there might be another scenario where um, you can't afford to do this. So you might have a use case, right, where let's say you have 100 terabyte of data. Then this is going to be very, very costly to do. So in those scenarios, you might rather than going with, a static storage approach where essentially here you're splitting them up separately, you can create views on top of them instead. You can maybe even stretch it to do materialized views and use the same approach. That way, the storage stays the same and the compute complexity reduces a little bit. But essentially, you can achieve the same thing. You might do that if you do views, for example. You might do that of the cost of latency. It's not going to be as fast. It's going to be heavy on the compute side. But if you do a materialized view, then it should definitely be more performant. So there's a lot to talk about in that aspect, but overall, if you go with this approach where you have static storage based on the same source, you separate them from each other, this works pretty well if your data is not too big, right? And if it's so big that this is going to become too tedious for you and the compute is going to be too heavy, then you need to start thinking about, okay, can I maybe create temporary views, or can I create materialized views and do the same thing? Or can I actually use the same table and have some kind of version tracker? So, user one, analyst writes version 5, scientist does some other change, and that's 6. And then you need to make sure that the live version is the version of before everything was altered. So that can be quite tricky, but that's also possible and quite an interesting approach. But that could be problematic if you're working with streaming, because that's pretty good if you do like full batch, full sync kind of operations. So if you want to do like a blue green data deployment with streaming, that's a bit different. But just to wrap up the batch way that we kind of see here is that given what every user is doing, whatever approach you choose, either if you do this clear separation on a bucket level or if you do it, with views or whatever, that ultimately leads to a point where you can decide, okay, this is the right version that I want, or maybe it might lead to that you need another version of that data set, and it might be an indication of that your upstream modeling is not right. Like you should also equally try to avoid to create hundreds of tables, right? Just because multiple people are doing multiple things. So this is more just for making sure that whatever you're working on, that it flows through smoothly and that you don't block people. And you need some kind of cleanup service once all this is done. You don't want this hanging around. So what about streaming then? Well, if you had a streaming framework that does this, then what I would do, I would not do this approach straight on the stream source. I would probably try and create some kind of intermediate layer from the streaming source. So essentially, you might have a cap architecture at your core, and then you can implement a Lambda solution downstream of that. Downstream of that. So you have something that goes and fetch batches of that data, and you do analysis on it. That way, you can use the same framework as you're doing here, but you can do it on top of a streaming source. So that's more in a research kind of way. If you have a strict requirement where you do need to do live testing on live streaming data, then probably you might want to go down the route of a dual sync operation where you might have like a retention of the last 7 days or something of that table so you can isolate it. But that's probably a whole topic by itself. Um, and so that's that really. So more or less, you can achieve a blue-green data deployment by this approach, and you can use various tweaks in between. Like I said, you could replace this for views or materialized views, do the same thing. And that's it really. So thank you for listening and have a great day.